when we people are designing any particular application. Okay. Now, types of displacement transducer. There are broadly, if we try to classify the types of displacement transducer, in that one, we are having contact type of displacement transducer and non-contact type of displacement transducer. What is contact type? When the person or the thing is directly in contact for the measurement of that particular parameter. Measurement of that particular parameter. So over here, if suppose this is one of the string and this one is the arrow, this arrow is in contact with this particular string and it may move to either this side or it may move to either this side. Then and then only the resultant output which we are going to get, suppose in terms of voltage, if it moves to this side, this one, here we have applied some supply, I will provide the example also. This is contact type. Now, another example for non-contact type, this is the body and this is the sensor which it is measuring. As it moves to this side or as it moves to this side, at that time, then and then also, it is measuring the displacement. It is measuring the displacement. That displacement may be your linear one or it may be it may be angular one. So depending upon the application, what type of application you are using, you can use contact type or non-contact type of displacement transducer, broadly classified as contact type, non-contact type. Now, what are contact type? Variable resistance. Variable resistance. Potentiometer is the best example for variable resistance type of transducer. Then variable inductance. Now, variable resistance, variable inductance and variable capacitance, these are different parameters. So here your resistance is going to change, here your inductance is going to change, and at the last here your capacitance is going to change. So each one is having different principle of the working. One by one we people will see all these three, and in non-contact type it is ultrasonic, optical sensor, proximity sensor, Hall's effect is there. In next lecture, we are going to see the non-contact type of displacement transducer, and in this particular lecture, we are going to briefly discuss about variable resistance, variable inductance, that is LVDT, RVDT, variable capacitance type of transducer. It means contact type of transducer, displacement transducer, we are going to see thorough. Now, resistive type of transducer. So if you try to visualize the figure, that is your linear potentiometer, in linear potentiometer, this is the displacement where it is taking place. If you see, this is nothing but this is the displacement which it is covering. Here is your potentiometer. This is starting from point A to point C is your potentiometer, and you people are well aware, this is the slider which has been connected to your potentiometer. Now this is the slider arm. What happens when this slider is moving in this direction or this direction? This slider arm will move back and forth. This will move back and forth. The motion back and forth is nothing but your displacement. Is nothing but displacement. But however, when it is applying or displacement is taking place, this is trying to move, your slider is trying to move either in the forward direction or either in the backward direction. So it is coming across the potentiometer. Now when it is coming across the potentiometer, at that time potentiometer, at that time its resistance of the potentiometer will vary, and in proportion to that your output is also going to vary. Now this output will be proportional to that of the displacement that has been that is taking place on this one, and this is working based upon uh, Ohm's law, that is R is equal V is equal to IR. But here we have shown that one of the formula, that is R is equal to rho L by A. Rho is the constant, L is the length, and A is the area. A is the area, and depending upon that one, here your length is varying of the slider, as your resistance R is directly proportional to the length. At that time, as your length varies, resistance will vary, and resistance varies, output will vary. Okay. So potentiometer are electrical devices which are a form of variable resistance. It consists of a sliding contact that moves over a length of a resistance element. This sliding contact connects to a plunger which links to the object whose displacement we people are interested to measure. Now, the example also represented over here. The previous example has been elaborated over here. Now, xt is the total displacement which we people can see. E is the applied voltage to this one, and E0 is nothing. This E0, this is the input applied for the excitation purpose, because this is not a active transducer, this is passive transducer. This xt is nothing but applied voltage, input voltage across your entire register from point A to point C. And this slider, this is nothing but a slider, this one is the slider, and xi is the measured output of a sliding contact. If you are go on moving towards this side, voltage E will reduce, because you have increased the displacement in the upward direction, means resistance in the path will increase or resistance in the path will decrease. Now when, as they have provided R is equal to rho L by A, you are changing the length as your R is directly proportional to L. As your R is directly proportional to L. At that time, what is going to happen? What is going to happen is, your length varies, resistance will also vary. As length varies, your resistance is also going to vary. So over here, the change in length is directly proportional to the resistance which is generating an output. So this is similar to that of the previous example. This is similar to that of the previous. Only for the elaboration purpose, I have shown this particular diagram. Okay. Another one is your angular displacement. Now, angular displacement, rotational motion is measured, and rotary or angular potentiometer measures the angular displacement. Now, here actually when we people are measuring angular, I would like to give the example of the potentiometer or the pot that is used to control the speed of a fan. How we people are trying to control the speed? It is, we are trying to provide a variation to the pot. And this variation to the pot by moving or providing input, or if you try to recall the pot, if you try to switch over on one, if you try to switch over the pot on 2 or 3 or 4 or 5, when you have switched the pot on 5, the speed of fan will be the maximum one. Why this is so? The resistance in the path which is coming across the voltage is the minimum one. That's why speed of the fan or the voltage received by the fan is the maximum one, and you people are getting the maximum speed for the fan. However, when you are trying to bring that rotation of the pot on one, the resistance included in the path is a maximum one. And as per as your Ohm's law, V is equal to IR, at that time your voltage will be reduced because voltage is directly proportional to the R and resistance in the path is more. That's why it is speed of the fan is minimum one. So here regulation of the fan or regulator of the fan is the best example for the angular displacement. Now, capacitive type of transducer. Capacitive type of transducer, actually it is the function. It is the function of area, distance, and permittivity. Area, distance, and permittivity. So, if I specify the capacitance, if we try to measure a capacitance of anything, you are going to get an output in variation or with reference to that of the variation in the plate. How we people are getting? Suppose I have considered the two plates. These are the two plates, and your capacitance is a function of, suppose I have considered T, that is the distance, A is the area, and epsilon is the permittivity. Epsilon is the permittivity. Now, this is the distance between two plates. This is the distance between two plates, and this is the area of the capacitive plate. This is the area of the capacitive plate. And the things that we people are using, or we are trying to use, that is the permittivity, means what type of material we are using. That material, depending on that material, permittivity is means provide. Now here also I have shown the structure of your capacitive type of transducer. If you see over here, that I have already shown you that what are the things to be considered for variation of capacitance and how we people are going to measure the displacement using capacitive type of transducer. So here are the two plates, and as per as my definition, that is my capacitance is a function of epsilon, that is nothing but the permittivity, area, and distance. Area and distance. So this is my distance. I will first of all specify this is nothing but my distance, and this is one of the plate. If I try to move this plate or increase the distance, this is also displacement, because we are interested in displacement. Whenever we are increasing the distance between the two plates, its capacitance will change. Its capacitance will change. But this change in capacitance is proportional to the change in displacement or distance of the two plates. two plates.